SUW 2000, Polish system of automatic wheel track change for freight and passenger trains. The development of the railway network at the turn of the 20th century brought about a significant diversity of the railway track width. Early European railways used the Stephenson engine, therefore 1,435 mm wide tracks became common in Europe. However, Spain and Portugal, separated from the rest of Europe by the Pyrenees, opted for the track width of 1,668 mm. In Russia, where railway construction began in the 19th century, still another track width of 1,520 mm was chosen. At present, the differences in track widths are the biggest obstacle in international railway transport. At the junction of different track widths, goods have to be reloaded or the bogies under all cars have to be exchanged. Difficulties resulting from different track widths will be presented on the example of Poland's eastern border. Goods are reloaded in special terminals. Parallel to the cars filled with goods, empty cars with a different wheel track are lined along the reloading ramp. All the goods are either carried over or, in the case of heavier products and containers, moved over by crane. This reloading system requires a large space, costly machinery and the labor of many workers. It is also impossible without a stock of empty cars. Liquid products must be pumped from one tank to another in designated areas. Another way to tackle the problem of different track widths is by changing bogies under cars. This solution is especially common in passenger transport. Before crossing the border, passenger and freight trains go through a station equipped with 2 tracks and special lifts. All cars are disconnected and lifts pick up car bodies from their bogies. The lifting of car bodies is shown on the film 30 times faster than in reality. Passengers remain in the car throughout the process. Now, bogies with different wheel track are rolled under the car bodies, pushing out the bogies used before reaching the border. The exchange of bogies in one passenger car is done by 3 people and takes approximately 40 minutes. To shorten the passengers' waiting time, bogies are exchanged in all cars simultaneously. 26 people working at the same time are required to man 7 workstations. The car bodies are lowered and connected to the new bogies. Only now can passengers continue the trip. Freight train bogies are exchanged 1 car at a time. Each car is worked on by 7 people and takes about 20 minutes. Approximately 200 minutes are needed to exchange bogies on 10 cars. Polish Railways is currently introducing a system that will eliminate problems resulting from different track widths. A group of Polish designers, led by a civil engineer Dr. Ryszard Suwalski of PKP Cargo SA, has developed the SUW 2000 system, which automatically adapts wheel sets to the 3 track widths used in Europe. The goal of the solution promoted here is to make it technically feasible for different railway networks to cooperate. The SUW 2000 system will allow a reduction in the customer service time and will raise the flow capacity of cooperating railway networks at low investment input. This innovative project has been implemented by Polish Railways, the rolling stock repair plant in Poznań, and the management of tanker transport. SUW 2000 systems are manufactured and assembled at the rolling stock repair plant in Poznań. An assembled blocking mechanism is connected to an axle sub-assembly. Among different axle elements are brake discs. After the wheels and the rubber guards are assembled, SUW2000 set is ready to be tested. Proper operation of all the system elements is tested at a specially designed station. After the proper work has been tested, wheel sets are connected to the bogie and the bogie is connected to the car. Wheel track is changed at a track shift station. The station consists of running rails, unblocking rails and securing rails. Passenger and freight cars enter this shift station at 30 km/h. This computer simulation will show consecutive phases of wheel track change from 1435 to 1520 mm. The flange of a blocking sleeve slides over the unblocking rail. The block of the rebounding sleeve is released. The released left wheel is shifted down the dock rail. During the wheel shift, the rebounding sleeve springs into the other dock. As the flange slides off the unblocking rail, it causes the blocking sleeve to slide over the rebounding sleeve. The left wheel is blocked at the width of 1520 mm. Now the right wheel rolls onto the unblocking rail and the cycle shown starts over. After exiting the shift station, the car is on a 1520 mm wide track. The SUW2000 system can also be used on even wider tracks of Spain and Portugal. A track shift station can be equipped with a sensor system, which will send information collected during the car's passage through the station to a computer. This system can be used as a diagnostic tool, registering basic technical data and signaling flaws in the shifting process. A computer registers and archives the whole passage. In 1999, on the border with Lithuania, a Polish track shift station was built, and since 2000 it has been operational in the railway traffic, utilizing the automatic wheel track shift system. From the Polish border station in Trakiszki, trains enter Lithuania on a 1435 mm wide track. A shift station is located at the Lithuanian station Mockava. Wheel track shift on train cars with SUW2000 wheel sets is done in the most efficient way, without reloading the goods. The wheel track is changed automatically in 5 to 10 seconds. After the first car has passed through the shift station, a Lithuanian engine with a wheel track of 1520 mm is hooked to the train. Freight trains running from Poland to Lithuania carry goods that used to be transported by lorries due to possible damage during reloading. The SUW2000 system eliminated the need for reloading goods on the border and reclaimed the market for railway transport. Since the year 2000, passenger trains between Poland and Lithuania have been equipped with SUW2000 system. Now passengers traveling on the Warsaw-Vilnius-Warsaw route cover the distance in a significantly shorter time uninterrupted. The design of the SUW2000 wheelset allows for it to be used in all types of freight and passenger cars. It has shortened the transport time and eliminated the high cost of reloading the goods and manning the bogie exchange stations. The system is especially beneficial in railway transport of hazardous materials, which could not be reloaded on the border. The SUW 2000 system that has been exploited up to the present, both in freight and passenger transport, confirmed its important technical and maintenance qualities such as failure-free system operation, reduced transportation costs, simplified clearance procedures, shortened travel time. Still this year, the SUW 2000 system will be implemented between Poland and Ukraine. Discussions are in progress with Latvia, Belarus and Russia. The railways of Kazakhstan, China, South Korea and Japan have expressed interest in the SUW 2000. Further information about the SUW 2000 system can be obtained from Polish Railways, the rolling stock repair plant in Poznań and the management of tanker transport.